Hi and welcome to Ping and Traceroute video lesson by Bellerophone. My name is Tomislav Alar, also known as Bellerophone, and I live in Croatia. I am a CCNA student with an ID number 6301592. In this video, we will learn how to verify TCP/IP network layer connectivity using Ping utility. Ping utility is available on Windows, Linux, and Cisco iOS. We will also see how a network administrator can check network latency using Traceroute or Traceroute utility. Traceroute utility is available on Windows, and Traceroute utility is used on Linux and Cisco iOS. Both of these utilities use Internet Control Message Protocol, abbreviated ICMP, to send messages between devices. This picture shows how ICMP header looks like. To show how these utilities work, we will use Cisco's Packet Tracer utility. Packet Tracer can be downloaded from Cisco Networking Academy webpage. Enough talking, let's start Packet Tracer and get to work. Now that we have opened our testing topology in Packet Tracer, we will verify TCP/IP network layer connectivity on one of PCs using command ipconfig. To do that, we will click on PC, enter its command prompt, and then use ipconfig command. This command will give us the IP address of that PC, his subnet mask, and his default gateway address. Remember that each PC that is on the same local area network should have the same subnet mask and default gateway address. In this step, we will use ping command to check connectivity between host 1A and host 11B. We will do that by entering ping command and then providing destination IP address, which in our case is 172.16.11.2. By default, 4 ping requests are sent to the destination and 4 reply information are received. From this output, we can find out size of the ICMP packet, time elapsed between transmission and reply, and returned time to leave value. From the summary information, we can see how many packets were sent, received, and lost. From this output, we can see that network layer connectivity between host 1A and 11B is functioning well, so now we can check connectivity between host 1A and its default gateway. Our default gateway has IP address 172.16.255.254, so we will use that address as destination address for ping command. Ping 172.16.255.254. We can see that returned time to leave value is 255. That is because Cisco's iOS default TTL value is set to 255, and because datagrams did not travel through router, the TTL value returned is 255. Now we know that we can ping other PCs on our local area network and our default gateway, but the question is, can we ping devices on a remote network? Let's try to ping Eagle server. Eagle server has an IP address of 192.168.254.254. Packets are sent and replies were received, so TCP/IP network layer connectivity is functioning well. Now we will turn off the Eagle server and try to ping it again. To shut down Eagle server, we will click on it and then we will push the power button. As you can see, the link between Eagle server and router R1 ISP is now down. Let's try to ping Eagle server. Ping 192.168.254.254. As you can see, this time we get destination host unreachable message. Let's pretend we don't know that Eagle server has been turned off. How could we find out what is the cause of our problem? Is there a problem with Eagle server or some device in the path to the server? If you're thinking about Traceroute utility, you're right. We will use Traceroute command to get information about network latency and path itself. Traceroute command syntax is similar to ping. We enter Traceroute and then provide destination IP address, which is in our case 192.168.254.254. As we can see, our default gateway responded correctly, as well as our one ISP router. That tells us that the problem must be on the 192.168.254.0 network with a 24-bit subnet mask. Two things could be the cause of this problem. One of them is that fast Ethernet interface of our one ISP is down, or the host itself is down. We know that Eagle server is down, so we are going to turn it on and try the same command again. So let's try Traceroute again. Traceroute 192.168.254.254. As we can see, this time trace was complete. In the Traceroute output, first column shows the hop number, and the next three columns show ping times between source host and that particular host. Last column shows the host name or the host's IP address. In the next video, we will examine ICMP packets in more depth, so stay tuned and thank you for watching.